All right, let's get out Group 2 FRQ packet. All right, now that you got Group 2 FRQ packet out, this one is going to focus on how do we plot data, find a best fit line, and sketch a graph. Now, plotting data, best fit line, that goes a lot with what to graph. So this is what to graph was all about us figuring out what things are going to go on the X and Y axis. All right, so the first one we're going to look at is this 2007 number 3. Now, they were nice to us on this one. They gave us what are you going to graph. We didn't have to figure it out on our own. But in case we did, we would read the problem and see, okay, it's looking at 2 points. It's looking at a point out here where it's all elastic potential energy, and then it's looking at a point right when it crosses x equals 0 where it's all kinetic energy. And so all of that elastic goes into that kinetic at that maximum velocity. And so they went ahead and they kind of solved it and they said, okay, you're going to graph v squared on the y-axis, x squared on the x-axis. So what is your slope going to be? Well, your slope is going to be the spring constant divided by the mass. Okay. So they kind of got us set up. All we had to do is plot our data, find a best fit line. So let's kind of talk about that a little bit. So the first thing you want to do is if you have to choose your axes, you have to write in what they want. Try and use as much as you can. I believe when I read these, typically it's as long as you use more than half. Okay. Sometimes it's more than a third, but usually as long as you're using more than half the graph here, they'll accept it. Because if you're using half, what should you have done? Doubled everything. Makes sense. Okay, so as long as you're using more than half of the graph, you're good to go. When you plot your data, that's fine, plot it. Make sure you put all the points on the graph where they're supposed to be. If you see any that look like outliers, double check to make sure that they didn't belong somewhere else. Okay, another one to be checking, if you see a curve, be kind of skeptical, look ahead. Are you going to be finding a best fit line? Because if you're finding a best fit line of a curve, you're going to have some real trouble on a graph like this. Okay, so it should be a straight line, in other words. When you get your straight line, when you draw it on there, one of the things to keep in mind when you draw your best fit line is you want it to go through 2 crosshairs so that you can get a nice slope from 2 numbers, and those 2 numbers should not be plotted data points. Do not use plotted data points because you're then saying that that plotted data point is on the line. Don't necessarily do that. Also, when you draw that line, make sure about some are half above, half below, somewhere in that. Now, this case, I drew 5 on there, so I'm going to have one where 3 are above and one where 3 are below. But you'll notice that their endpoints are different. What that means is they have different intercepts. So something to kind of keep in your head when you're drawing these is this going to have an intercept, and what does that mean? Okay, so the idea is this. If I don't stretch the spring any, so this is 0, what's the maximum velocity it's going to reach? 0. So I should have this going through the origin. So keep that in mind when you put your best fit line on there as well. If it doesn't, that's telling you something. And so that intercept means something. So kind of keep in your head, well, what could that intercept be telling me then? All right. And then lastly, when you draw these, make sure you label your axes with what they are and what the units are on them. Okay, so the next thing we're going to look at is we're going to look at the other problem, and specifically we're going to look at sketching graphs. Okay, go ahead, solve this 2007 number 3, check the answers in the scoring guide, and then you can move on to that next one. Before you start it, of course, watch the next part of this video. Let's change the board up, huh? All right, we reset the board here. So what we're going to do now is we're going to look at sketching. Now, I don't want to give this one away and tell you what the sketch looks like, but I want to bring up some points that you got to keep in mind when you make the sketch for part B on this problem. So some things to make sure you identify, if it has any, that is, asymptotes. If there's an asymptote, identify it as an asymptote. Other fun fact, learn how to spell asymptote, because there's nothing worse than getting to the AP test and going, well, there's no way I can get a 5. I can't even spell asymptote. So learn how to spell that word. That's helpful. All right, so identify an asymptote. Tell me what it is. So in this case, I have my velocity speeding up to some terminal velocity. I'll call it VT. Identify any intercepts. So my initial velocity, now maybe I was doing a problem where I knew the initial velocity was 5 and I knew the terminal velocity was 20. Okay, so maybe I would label those specifically. Okay, also make sure you label your axes. Make sure you put units on them if they need units. In my case, I just had variables, so I didn't put units on it. If you had specific numbers you were putting on there, make sure you include units. Any known point. If you know a point where a graph transitions, maybe a person starts walking and then stops walking, okay? Identify those points on your graph, okay? Maxes and mins are good points to know what are those maxes and mins, solve for them, and then just, say, hey, I know what this point is right here. This is the point when it was at, some certain velocity at some certain time. Maybe we solved for it. Okay? Also, something to be kind of conscientious of, make concavity clear. Make it very clear that that is a straight line right there versus a curved line. That way the grader knows, hey, they are very much making a straight line or they are very much making a curved line. That one's going to come into play on this graph you're going to make here. If you don't know if it's straight or curved, yeah, do your thing and hope they give you a credit for leniency, I guess. All right, so there's your hint. Go ahead and solve that problem.